So I just got back from my morning walk, and I couldn't help but think there was a student who I was working with yesterday who was asking me about quadratic equations. Now, this student is a student who has been in industry for a while, and they were confused why they should be focusing on quadratics when they've been working a high-level job for a number of years, and it's never come up before. They've worked with data, they've worked with graphing. Well, why have they never seen these curves? They're used to dealing with trend lines. What is this quadratic thing? And I love this question because this question tells me that a student is engaging with their own learning and they're attempting to integrate what they're seeing in the classroom with what they've experienced outside of the classroom. And so I'm really happy to answer this question. And I kind of just want to take some time now to talk through this. Now, the first thing I want to talk about is what exactly do we mean by quadratics? And so quadratics are in the math classroom usually represented by their equation. And this is going to be something of the form like ax squared plus bx plus c equals maybe y, or we write this as f of x. Sometimes we just see things like x squared. Sometimes we see fancier notation like b1 x squared, b2 x plus b3. There's a lot of different ways to write these, but what we're talking about is a structure. It's a behavior. There's a behind the scenes occurring. And to understand that, let's first take a moment and just talk about variables, a quick refresher. When we talk about variables, we're talking about usually the letters from the latter part of the alphabet that appear in the structure. This is a loose rule, but it's something that's normally followed. So you have variables, which are numbers that are allowed to change, values that are allowed to shift back and forth, and we usually represent these with x or y or z. You also just sometimes have numbers that we don't know, but they're not shifting, they're just, we don't know what they are. Like if you were to wonder what my birthday is. My birthday is not a number that's going to shift around, but you might not know it. So how do we represent this idea of something that's unknown but not shifting? And what we call those are unknown constants. So we're just going to say unknown constant. And normally we represent these with the earlier letters in the alphabet. These will be our A's, B's, or C's. It's just a standard notation, but you're allowed to change it. Sometimes we use M's for the unknown constant of slope. Sometimes we use K, which is normally because I think it just sounds like the C in the word constant. Point being, this is a behavioral structure that always results in a certain shape. And so let's take a look at what that shape is. If you jump over to GeoGebra, you're to type in equations in a very generic way, and most of the time it recognizes exactly what you mean by it. So let's go ahead and type in ax squared plus bx plus c. And if I click enter, you'll see that it chose to assume that what I meant by a, b, and c were numbers. It didn't know what the numbers were that I wanted, so it just randomly assigned 1, 1, and 1. But I could change these, and I could make this to be 2.1. I could make b to be a negative 1.3. I can shift c around. And as I do this, I get to see how the graph behaves. But one thing you'll always notice is that the shape is this U-type shape. And so that's the result of all of these different kinds of equations. Ax squared plus bx plus c is to give us some kind of U-shape. And it could be a U-shape that's quite flat. It could be a U-shape that is upside down. It could be a U-shape that's incredibly skinny. But it's always going to be this kind of U-shape. Why do we care? Where does this come up? Well, originally, it came up when people were talking about squares, literal squares. If you were given, let's say, a length of 5, and you were trying to square it, that literally meant create a square where the sides are length 5, and then count out how big that is. So that would be 25 units large, right? That gets us this idea of 5 squared. Now, way back in the 3, 4, 5, and 600 BC era, geometers were just beginning to recognize that they could predict how stars moved in the sky, how you could determine the time of day based on the sun's shadows, and all of this tied back into certain shapes, including the parabola. By studying parabolas, they were able to do some pretty amazing things. First of all, they were able to recognize that if you built a mirror in the shape of a parabola, you could actually light an object on fire based on how the light was coming in and it was reflecting outwards. This actually led to some of the best theories of war machines developed all the way back by Archimedes, and how he would supposedly have built death rays to burn incoming warships. Now, parabolas were also used when you were talking about sundials, because you could estimate how the sun was traveling through the sky using parabolas. We later learned they were for hyperbolas, but that's neither here nor there. So the idea being that parabolas came up very often and were very, very useful in a practical sense. They were also a lot of times used as a riddle for each other. So for example, if I was to ask you, let's say that I have two numbers in my head, and I know that they add to the number 10. And I also know that they multiply to the number 14. Could you figure out what those numbers were? Now, these little riddle challenges were asked all the time between great minds as a means of challenging each other. And in an era before TV, magazines, and other kinds of entertainment, this was sport. This was a means of kind of besting your opponent, if you will. And it turns out that in order to answer this equation, you need to be able to use parabolas, or at least the quadratic equations. Okay, but why do we care about them now? Today, they're often used as a means of trying to determine an underlying structure to something we don't fully understand, like a data set. So let me give you an example that you're probably familiar with. I know that when I was studying for a test, or I was trying to cram the night before, it was because I was worried I was going to get a low grade. So let's kind of flesh this example out a little bit. Let's say that I think that I'm coming up on a test tomorrow, and I think that right now, if I was to take it right now with my current level of understanding, I would get a 50%. Okay, quite low. But maybe if I was to sacrifice an hour of sleep tonight, I could bump that up to a 58%. And then maybe I could sacrifice another hour of sleep, but now I'm kind of getting tired, so instead of jumping up 8 points, maybe I think that I'm just going to jump up 6, so that would get me to 64%. So I'm still doing good. I'm just starting to lose some sleep, some cohesion here. Maybe I could then, the next hour of study, that might get me up to 68%. I've got tapering results. Maybe after that, I could get up to a 70%. And at this point, I normally sleep 8 hours a night, and that's about 5 hours, 4 hours I've sacrificed. I started right here. Sacrificed 4 hours, and I'm at half my sleep. At this point, I'm thinking that if I studied more, I probably wouldn't get much more in terms of understanding or ability to perform the next day. And if I kept pushing myself even further, I'd probably begin to just become sleep deprived, and I probably would start to do worse, and then I'd probably do worse again. Well, if I was to study 1,000 students and they all showed similar behaviors, I might want to understand and predict exactly what's the right amount of time to give up on sleep if worse comes to worse and you have to cram before an exam. How would we figure out what the structure is? Well, there's plenty of software out there, but my favorite is always to use something like Excel. So here we have a simple Excel document, and let's just type in what we know. So we know that if I was to go to sleep right away, so that's 0 hours of study, that I was going to get a 50%. And then if I was going to have 1, 2, 3, 4, 5, 6 or so hours, that I would then get maybe a 58 on my test, I predict, or a 64, and a 68, a 70, a 70, and then I would go back down to probably a 68, a 64. I'd begin to taper back on that other side. But what is that shape? I can graph all of this by just saying insert a scatter plot, and I can choose the equation I'd like to have. So I just right-clicked on here and I can say add trend line. And you see that when I say add trend line, it thinks I'm literally asking about a line, that I'm talking about doing a trend line. But the line fits this very poorly. And so I probably want to be looking at like a trend curve. So as we discussed, we have an option here for polynomial, and I can make that of degree 2, and look at how much better this fits the data. Now I've got a very simple curve that explains why it is that I might be tapering on either side of some kind of optimal point. Well, we could also display the equation right here, and we'll see that, again, it looks just like the equation we started with, this negative x squared plus 9x plus 50. But this negative x squared, where is the square? I wasn't talking about squares at all. I was talking about sleep. and studying, where is a square appearing? Well, let's break that down a little bit. So I've got negative x squared plus 9x plus 50. And here's a really cool trick that you can do when you're looking at quadratic equations. Just try to make them simpler. If the x squared part is the thing that's throwing us off, let's see how I might be able to break that apart to something simple. And so here's what I did while I was playing around. Not my first idea, but one of the ones I stumbled upon. If I rewrite this by factoring out that x, things become very clear. The 50 here makes a lot of sense to me because it's exactly where I started with. Sometimes we would call this my y-intercept. So it's where I started my behavior pattern, and I'm going to change it by stepping up. Well, where does these steps come from? These steps come from hours of study, right? This is 1 hour of study, and this is 2 hours of study. So this x part here is my hours of study. It's my hours. What is this? Well, this one took a little bit of time, and so what I tried to figure it out was I just tried plugging something in. Let's try plugging in the number 2. If I plug in the number 2, I'll get 2 minus 2 plus 9 plus 50. And all of this together is going to get me that 64. And so what this is 2 times 7 plus 50. And now it makes a little bit more sense to me. This 7 is the amount of grade bump I get over those 2 hours per hour. So it's kind of what's going to taper down as I begin to get more tired. It's my lesser overall average impact. So you write this out, this is going to be my hours. This is going to be my average grade bump per hour. A little average grade bump per hour. And this is going to be where I started from. So where does this squared come from? There's an interaction effect that's happening. I've got an interaction between the number of hours that I'm studying, which should help me. I should be getting a better grade as a result of that. But then I've got an interaction that's occurring with the loss of performance due to sleep. And this interaction is what's literally being represented metaphorically in this square. It's like as I increase this side goes down, and I've got some kind of interaction, this square that's always going to be present as a result. Okay, this is a little bit weird, but let me kind of show you also how this has actually come up in a non-figurative example. This is some research that I actually conducted with my students when I was doing my thesis. And what I wanted to figure out was, is the homework that I'm assigning matching up with the tests that I'm giving at the ends of the units? And what really I was trying to ask on that was, if students spent time pursuing 100% on homework that they could redo over and over and over again, did that result in them getting better scores on the tests? Was I asking the right questions? Was I assigning the right homework? And this is the result that I got for the first test and the midterm. These are absolutely legitimate data scores. And so I had to kind of create a prediction model for this. Was this something that I could hang my hat on? Was this something I could use to predict with very good accuracy? Well, let's do this together. If I tried to treat this as a line, right, the most simple thing, because it looks like it could possibly be a line, maybe I'll just do, let's do the orange. There's a few more data points for that one. I could combine them all together as well, but we'll just go ahead and do the orange for right now. So let's right click on the orange, and we'll say add a trend line in the same way we just did. This is my trend, and it's a pretty good trend. It's not anything special, but it looks like it's generally going up. But look at all of this missed data that I have here. I really can't explain why there's much here that's below the line. And then I thought to myself, maybe it's not a line. Maybe it's a parabola. So we can actually check that by changing this to a polynomial of degree 2. And lo and behold, this seems to fit so much better. And that tells me that there's an interaction that's happening. And that made me wonder what that interaction was. So here's my thoughts. My thoughts are that I have two groups of students. I have those students who are choosing to do none of their homework, They're simply ignoring it entirely, and as a result, they're getting low C's and high D's. These, to me, are the students that are saying, I will not do the extra work because I think I will perform well, or perhaps I'm distracted, or perhaps there's other inconveniences or other barriers to my doing the homework on a regular basis. And as a result, they're not picking up some of the knowledge that I'm putting there for homework. I also then have some students who are maybe starting homework and not finishing it. So these are maybe the students who are struggling on the concepts. But then I also have students who are pursuing strong homework grades, and as a result, they're picking up some of their material. And this tells me that I've got kind of two competing emotions and thoughts in my students. Those who think that they're doing well, and in fact are not, and those who maybe only believe they're doing well when they've gotten 100% on all of their assignments. So that's quadratics. Now, why is it that we don't see them very often? Well, I'd argue that we do. We just might not always have the awareness to recognize it. If you, again, throw something up in the air, you'll see that it's going to travel in a parabola. If you look for these interaction effects, whether they be in profit, or whether they be in sleep, or whether it be any kind of push and pull that behaves in a traditional, steady way, you're going to see quadratics pop up. But here's where I think we can improve our recognition of it. Instead of looking for certain situations that have some data, and maybe the data looks like it's all over the place, instead of just immediately assuming that it has to be a line that fits this data, maybe consider what would happen if it wasn't. Is there maybe some other data that's outside of this range that would actually allow us to maybe better estimate this structure as a parabola? Because over small little bits, they're going to look the same, and it's going to be very easy for us to discard all the rest of the complication and just simply create a trend line. But if we can estimate things with a better structure, we get more insight into where they might actually be coming from. Alright everybody, that's it for this video. If you enjoyed and are watching this on YouTube, give it a big thumbs up underneath to let me know and to help reach out to more students. And I'll see you in the next video.